Okay, so for this lesson, we're moving into fractional indices. This is something you probably haven't seen before. It's the sixth index law, and it's kind of closely related to Surds, which was the front of this topic. So it sort of links this work we've been doing on indices with what we've been doing with Surds. And what happens with our fractional indices is this situation here. If we've got a fraction where it's 1 over some value, that's the nth root of whatever the base is. So the example here given is that 8 to the power of 1/3 is the cube root of 8, which equals 2. And then we've got further down below is where we've got a situation like this where we've got a fraction and it's not 1 over, it's some other value as our numerator. Then we can just really think of that as 1 over n then multiplied by m. So we can sort of break this up as it is there and sort of understand how that works. So as you can see the next example there, 8 to the value of 2/3, that's going to be the cube root of 8 because that's what the value in the denominator determines the surd. And the value in the numerator is still just a normal power and we can multiply that out. So just dealing quickly with the y. We can see here, if I had x times by a half times by x times by a half, well, that's going to be x equals a half plus, x to the power of a half plus a half, just using our normal index laws, which of course a half plus a half is 1. So we can see that x to the half times x to the half is going to give us x to the power of 1. But really, what are we saying there? We're saying if we take two things that are exactly the same as each other and multiply them by each other, we end up with x to the power of 1. So the only thing that would fit that particular scenario is the square root of x. If I took the square root of x and multiplied it by the square root of x, I'm going to get x, because this essentially is the square root of x squared. And once again, that's going to equal x. So that's how we end up with this particular rule, just so you sort of understand where it's coming from. So we're using those earlier index laws to create the later index laws. So just going through the examples here. First of all, we've got to express these in index form. So 13, the square root of 13, we could also just write as 13 to the value of 1 over 2. Why 2? Because it's a square root. When we see this symbol here, it's basically the same as having that symbol there, which we never do. Sorry, I'll just make that a little bit clearer. Generally, we only ever put the power there if it's more than 2. So, but it's much like we don't put a multiplication symbol between 7 and x, we just call it 7x. We don't put a 2 on the surd if it's just a square root, we just leave that blank. So looking at the next one, I've got 5x to the power of 7. All of that is under the surd, so all of that is to the value of a half. Okay, not just the x to the power of 7, because the 5 is in the surd. Now in our next one, we've got another surd, but this time it's to the 5th power. So we still keep everything other than the surd in brackets, and this is going to be to the power of 1 over 5 because it's the 5th root. Now in this next example, the only thing under the surd is the x to the power of the 7. So we've still got 3. And it's going to be by x. Now, we would in the previous examples, we'd go 1 over. So we'd go 1 over 4. But in this case, x is also to the power of 7 under that surd. So we'd put that as 3x to the power of 7 over 4. The next example is a little bit of an interesting one. We can think of this as really just 7 times by 7 to the power of a half, because that's what the square root of 7 is. But of course, using our index laws, we can add those. We add the indices, so we end up with 7 to the power of 1.5, or we might write that as 3 over 2. Now, for our next example here, I've got some things under the surd, some things not. So the 2 is going to remain not under the surd, but both the m squared and the n are under that surd, so they're to the power of a third. And I could, if I wanted to, then break that up. I could go, well, that's 2m to the power of 2 over 3, n to the power of 1 over 3. Okay, going through the next lot of exercises, we're going to express these in surd form. So 4 to the power of a 5th, that means we're going to take the 5th root of 4. So we're going to take the 5th root, and the number under the surd is going to be 4. For the next one, we're going to have 7 to the power of 2 over 3. So essentially what that's going to be is 7 squared cube rooted. All right, so whatever's in the denominator becomes our surd. Whatever's in the numerator is still a positive power that we give to the number. In our next example, now we've got x to the power of negative 3 over 2, so we're joining in those negative indices we dealt with in the last lesson. So in this case, we're going to end up with 1 over, and then our x is going to be down here. So this is going to be the square root, because 2 is the denominator, of x to the power of 3. So we've got rid of the negative by putting in the denominator, we've got rid of the fraction by creating a surd, and we're just left with the integer power. Evaluating without the calculator, so 16 to the power of a half, well that's just the square root of 16. The square root of 16, I'm hoping you guys are all pretty comfortable with saying that's 4. For the next one, we could just rewrite this first as a surd. So we're going to end up with the cube root of 8 to the power of 4. Now we can do this in whichever order we want, and I think I'm going to do the cube root first. So the cube root of 8, well that's just going to be 2. So we're going to end up with 2 to the power of 4. Now 2 to the power of 4 is 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 again is 8, times 2 the fourth time gives us 16. And finally now we're going to rewrite this one. The negative is going to make a fraction, so we're going to end up with 1 to the power of the square root of 9 cubed. Now, once again, I think it's probably going to be easier to deal with that square root before we deal with the power of 3. So I can just deal with the square root first. The square root of 9 is 3, so it's going to be 1 over 3 cubed. 3 cubed is 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. And that's how we do those ones. It is one of those areas of maths where we just need to do a bit of practice with it and get used to. Make sure you know that the denominator is determining the surd and the numerator is still just a power that's being applied. So make sure, once again, like I've said a few times now, our main focus, particularly while you guys are not at school, is getting through into this first blue section. So in today's, that's questions 4 through 7. I'd like you to continue on, but really make sure you've got those questions. You can get them out and you can make them work. Check the answers. If you can't get the answers, if you're getting them wrong, see what it is you need to do to get to the right answer. And because you've been all so wonderfully good today, I'll finish with an unfortunate skiing person. And I know you can hear the audio on this one, so I won't talk over it.
Through the S turn, Yannick Bertrand.
So there you go. Something for probably the fellas today. Have a good time with that. Leave me a message on Classroom if you're having trouble with it. And otherwise, I will catch up with you guys for the next lesson. That'll be all the content for week 10. That leaves us 2 lessons to cover in week 11, which will finish up the topic and have you guys having a nice restful break. I will post on Classroom when our next Zoom session is, so make sure you jump on there, come and join the Zoom session so you can ask any questions and we can have a bit of a chat. See you later.